and magnitude of f3, which is these two added together. So if you add these two vectors together, it just creates this vector. Basically makes a right triangle. So do you guys remember what direction means? It'd be like the angle. If we found this angle and did 180 minus that, that would give us this angle. You could say it's that many degrees. Or you could say find this angle and do like that many degrees north of south, east of south. Doesn't sound right. Alright, what about magnitude? You guys remember magnitude? Yeah, it's the length of the vector. So how would I find the length of this vector? Yes, Pythagorean theorem. 5 squared plus 12 squared. Do you guys remember this one yet? 5. 13. Yeah, 5, 12, 13. Yeah, so magnitude, which a lot of times we used, the book used absolute value symbols to represent magnitude, so that would be 13. How could we find this angle right here? Yeah, trigonometry. So relative to this angle, we have opposite and adjacent. We could use that too. Opposite and adjacent are tangent. So tangent of the angle equals opposite over adjacent. Then what do we do? Tan inverse. So, and then that would spit out the angle. I'm curious. Yeah. Sometimes we did this angle like this is 0 degrees, so I'm curious how they wrote their answer. There's different ways to write it though. I would probably go with this angle. Do 180 minus that to get that angle. Alright. Thus. Yeah, but that wasn't me. Yeah, 2 is kind of a pain, but let's go ahead and look at it. Alright, so an important note in the directions, maybe I should draw this actually.
You were marked out.
It wasn't me.
Sebastian already said that. That you already said it wasn't me. My bad, bro.
Did I get them all? Alright, so it says AT to TC is a 1-to-2 ratio. I didn't draw it quite right, but so 1-to-2 ratio. That means this one twice as long as that one. Okay, the first thing is how do you get, using vectors u and v, how do you get vector AB? So vector u goes like this. So how do I get vector AB? Well, it's just u backwards. It's just u backwards, so it will be negative u. Okay, negative makes it go backwards. Second one, how do I get vector AC? So on this last one, this vector plus this vector just gives you this vector, right? So, oopsie. How do I get vector, how do I get from here to here? Using these two vectors. There you go, here, and then here. How do we do this?
Negative u.
Yeah, negative u. And how do we do this? Plus v. Vector AT. All right. So we just did this vector on the last one, and now they just want us to go from here to here. Vector AT. So vector AT is just a fraction of vector AC. What fraction, if this is a 1 to 2 ratio, what? Wow. That
That's
is,
my alarm, bro.
you have your volume set to grandma settings.
Bro, because I won't wake up myself. It was an honest mistake, Mr. Jordan. Wake up, bro.
That's what it's like last.
I have like 50 more sets.
You already have a plan
I have
to be
them.
late to school.
Huh?
You already just have a plan to just be late to school.
Yes.
Yeah. Is it set every day for that or just Monday?
No, that was my plan to be late to school. That was for the weekend. There's no way I ever got any for the weekend, though.
Okay, okay. So we just did vector AC. What fraction is vector AT of vector AC? It's 1 out of how many? No, 3. From here to here, it's 3 long. And this is 1, so it's 1/3 of the way. So it's 1/3 the length of this. So you could just do 1/3 times that. Alright, what's the last little trick? BT? Man, I cannot get that song in my head. BT, so that would go from here to here. So we could do like this one plus that one we just did. Was that one? So U plus that thing. I guess this would simplify a little bit. This is like 1U minus 1/3 U. So that'd be like 2/3 U. That's kind of a mess. All right, number 3. I feel like we did a lot of these this year. A plane is on a course of 320 degrees. Where's 320 degrees at? If we're doing like planes and boats, stuff like that. Where is 320, huh? No.
Top left.
Yeah. So here's 0 when you're doing like planes and boats. And when you go all the way around, that's 360. So 320 would be 40 degrees short. So it'd be most of the way around. It'd be 40 degrees short. 360. A plane is on a course 320 degrees at a speed of 480. So the speed would be like the magnitude. That's how long the vector is. 480 miles per hour. What are the north-south and east-west components? Alright, well, if this one's 40, what's this one right here? 50. We could use this triangle to do it, like draw a line there. Prefer this one. 50 degrees. So the east-west component is basically the x component. How far is it going in the x direction? The north-south component would be the y component. And how long was that? 480. Alright, so how do we find x? Yes, trigonometry. Relative to this angle, we're looking for the what side? Adjacent, we have the hypotenuse, so that will be cosine. So cosine of 50 equals adjacent over hypotenuse. What do we plug in the calculator to solve that? Times 40, yeah. You could do 40 times cosine 50. Okay, same thing for y, except for y is the opposite in this hypotenuse. Opposite hypotenuse is sine. So it's sine of the angle equals opposite of the hypotenuse. So you do sine times 480. How did you girls do?
About fours.
Out of like 8?
I don't know. It was a long day.
How many games did you play?
Probably 4 or 5.
Were they different teams?
We played,
For every,
like, we played one team twice.
and still get valid.
So you played 4 different teams? Could be 8.
Who's gonna pass that?
You guys remember this one? Okay, A is at 1, 3. So when I did these, I never worried about the graph too much because it's kind of a side point. I do remember, I believe that a lot of people miss this one for a reason. I feel like I remember that. Okay, it's find the fourth point. If this is a parallelogram, yeah, what does point D have to be? Okay, a lot of us got this wrong on the test because you did something like A, B, C, D. Why would that be wrong? So you have to go in alphabetical order. You either go A, B, C, D, like in a circle, like around the shape. So it's either A, B, C, D, or you could do A, B, C, D. So the order of the letters does matter. I'll screw it up. So if you go like zigzag, it would get it wrong. Okay, you guys remember how we found the coordinates for D?
A is to D and B is to C.
Yeah, basically. Because parallelograms, they're going the same direction and the opposite sides have the same length. They're basically like the same vector. So whatever vector gets us from here to here will get us from there to there. Or you could even go this way. Whatever gets us from here to here.
So 1, 0.
Yeah. From B to A, it's going, X is going up 1, Y is going up 0. Now my picture is not accurate at all. It doesn't really matter. Just the numbers kind of matter. So, did I copy that right? It seems 2. Oh, this is the -3. Okay. Now that'll change a little bit. So now it's going up 1 and the Y value is going up 6. Sometimes we get that wrong too because you might put like a -6 or something, kind of get confused. From -3 to 3, 1, it's going up 6. Or you could say 3 minus -3 is 6. So to find D, we need to move 1, 6. So 5 plus 1, 0 plus 6. If you know how to do it, that's an easy one. I'm afraid we did the zigzag. Some of those, not all of them. Okay. Find the velocity and speed of an object that moves constant velocities with the position 10t. This equation. So -2 is kind of like the starting point, and 1, 4 is like the movement vector. They called it the velocity. So this is kind of like on a graph, -2, 2, -2. So it'd like start over here, and then it would move right 1, up 4. It's not really a graphing problem. And then if t was 2, it'd move right 1 up forward again. It just keeps going like that. And you could go backwards too. So like t could be -1. Go backwards. Anyway, that kind of moves it along the line. It's kind of basically a linear equation, but just written in vector form. Find a pair of parametric equations of the path of the object. Alright, this was the easy one. Once you guys see it, you'll remember. You guys remember parametric? What's the x value going to equal? -2 plus 1t. Or you could just say -2 plus t. You guys remember that? So the y value would be -2 plus 4t. It's kind of like just separating the x and y's into two different equations. Okay, that was B. Oh, there was questions on A. So, okay, question 1 on A, what's the velocity? Okay, that's the 1/4 thing. I guess I'll just write like this. A lot of books use this for vector notation nowadays. They don't use the parentheses. I think these books are a little bit outdated. Velocity is just 1/4. The speed is how far, that's kind of like the magnitude. How far would it be moving? 1/4. So you do a little Pythagorean theorem, 1 squared plus 4 squared. Is 17, so this would be like the square root of 17. So the speed, you might have put that as a decimal. Probably. Okay. Yeah, I don't think we did C on that one. Okay, number 7. I think this was the hard one in this chapter. Given the points ABC, find the measure of angle A. So if finding the measure of angle A, B and C need to be on this. A needs to be in the middle. So the first thing that we did was we found these two vectors. These are A and B and C are points on the graph. They're not vectors. So what would a vector AB be? So from 1 to -2, how far is that moving in the x direction? 1 to -3. Right, it's going down 3. And from 3 to 7,
4.
moving up 4. Okay. We'll call that like vector U. You could just call it vector AB, but there's a formula that goes with this. So. And vector AC from 1 to 0, and from 3 to -6. Okay, if you're not sure how far that is, you could do where you're going minus where you started from. -6 minus 3, -9. Alright, and we'll call that vector B. Do I remember this formula? I might have to check my work on this one. Oh, dot product. We haven't talked about that yet. Okay, so what did I say the absolute values meant?
Just making positive.
No, it means magnitude. Magnitude, how long the vector is. So you do magnitude times magnitude. Okay, dot product, we haven't talked about that today. You guys remember dot product? Alright, so it was not hard. This was not the hard part of the chapter. You just do x times x plus y times y. X times x plus y times y. Okay, that would be the dot product. These are just two numbers multiplied together. These are two vectors, the dot product of two vectors. So that is a little different. Why don't you guys see if you can figure that out in the next minute. Go. Chapter 6, the chapter test we just took last week, will probably be on the test as well, so you need to make sure we won't have time to get to it today or tomorrow. So if you want to watch the review, you can go back and watch last Monday's chapter review. But hopefully it's a little bit fresher in your minds. This is 3 minus 36, so it's negative 33. Anybody get this part? I'm afraid to ask. Nobody? It's the magnitude. How do we find the magnitude? Yes, Pythagorean theorem. 3 squared plus 4 squared. Okay, 3, 4, what kind of triangle? 3, 4, what? Yeah, 3, 4, 5 is the right triangle. Anyway, that should come out as 5. 1 squared plus 9 squared is 82, so this will be like the square root of 82. Okay, you don't really need to simplify all that because cosine is equal to all this. So how would I solve this for? Yeah, cosine inverse of all that jazz. So this is a formula. It might be on the test. I don't really know. Maybe. To find the angle between two vectors. That's what it does. Finds the angle between two vectors. All right. All right. And we did some 3D stuff a little bit. Okay, so the length. How do I find the length between 2 points? This will be on the XYZ coordinate distance formula. Yep. So this is the 3D version of the distance formula. So instead of just x minus x squared plus y minus y squared, it also has plus z minus d squared. Okay, and do you guys remember the midpoint formula? Right. You average the x values for the x coordinate. You average the y values for the y coordinate. In this case, the 3D version, you average the z values for the z coordinate. Do you guys remember graphing these? Usually we made it look like this. Which axis was this? The one coming at you was x, going to the right was y, and this was the z-axis. Sometimes we needed like the negative axes. I don't know if we did a negative x-axis. Maybe we did. I think we just used some negative y, negative z. Alright, anyways. Pretty good chance those will be on there, I would say. Is that all we did this chapter? It's short.
We did the matrix.
Not this chapter. We did something else. But it might not be on this sheet, I think. Alright, well, this will call it good. I don't think we did the rest of that stuff.